Good morning, friends. I am Dr. Gnanasekar, Associate Professor, Department of Medical Electronics, Savita Engineering College. Today, I am going to discuss about a topic, electrophoresis, which is the fourth unit of Medical Instrumentation subject. Electrophoresis. This is the main option in clinical laboratories where you're going to find for various devices which is being used to fetch the electrophoretic principle, and these devices are used for the following applications: to measure the quantity of protein in plasma, urine, etc., to separate enzymes into their components, isoenzymes, to identify antibodies. The basic principle is electrophoresis is defined as the movement of solid phase with respect to a liquid, that is nothing but a buffer solution. A buffer solution is used to carry the current and to maintain the pH value of the solution as a constant, 1 during the migration. Here, the electrophoresis explains in simple is applied to a medium, and under the effect of electric field, group of particles that are similar in charge, size and shape migrate at the same rate. So the particles are separated into different zones based on the charge, size and shape. The main factors which affects the speed of migration, that is, the factors mainly involved in making the particles move. One is magnitude of charge. The mobility of a given particle is directly related to the net magnitude of the particle charge. Mobility is defined as the distance in centimeter. A particle move in unit per unit field strength. The second is a ionic strength of buffer. If the buffer is most concentrated, the migration will be very slow. The greater proportion of buffer ions present, then greater the proportion of current they carry. And third is temperature. Mobility also directly related to temperature. Heat produced when the current flows through the resistance of the medium, so the temperature of the medium is increased and resistance is decreased. Hence, the rate of migration is increased. So, constant current sources are used to minimize the heat production. So, and fourth is time. The distance of migration is related to the time period during which electrophoresis takes place. And finally, the type of media, that is the medium. So, cellulose acetate, starch gel, and sucrose are such as support media in various electrophoretic applications. We can see the cellulose acetate electrophoresis in the following section. So this is an example, and this is a major option which is used as a buffer solution. So cellulose acetate strip is saturated with the buffer solution and placed in the membrane holder. It is otherwise known as bridge. The two elements of the bridge are placed in the cuvette in which buffer solution is available. The sample for each test is placed on the strip at a marked location. Then the constant electric potential, about 250 volt, is applied across the strip, and 4 to 6 milliamp of initial current is obtained. After 15 to 20 minutes, the electric voltage is removed. Then we can notice the migrated protein band is strained with buffer and it is dried in preparation for densitometry. So here the graph indicates how the membrane density of albumin as an example. Initially you can see at a peak voltage where we have about our initial electric potential, where the migration is very strong, higher, and later on the migration distance is faded out. So this is a setup where the membrane is placed as a bridge, and the acetate solution which will act as a bridge, and the potential which is applied at both the location of Kuwait or at a buffer solution. Now you can see the marked position will be nothing but a solution where it has been lifted out and migrated over this acetate bridge. So now in the acetate bridge you can see the separation of that is the migrated ions or the migrated substance which is present in the solution. And this is the dosimeter, densitometer, the path of migration of one of the specimen is scanned. The low voltage output is amplified and recorded using XY recorder. And we can notice the waveform. So thank you.